Hello, you're watching Engineering with Ethanol, and this is Trugainz for Smoothbrainz. Today, we'll be talking about Sierpinski triangles. What is a Sierpinski triangle? It's a triangle.
But it's a fractal.
Okay, let me show you how this works. You take the one big right side up triangle, and you put a smaller one inside, upside down. Now you have three small right side up triangles. Next, you treat each right side up triangle like it's big, and you put a small upside down one in each. Now you have even more right side up triangles. And you basically just repeat this process until you get bored or your PC crashes. And you can fill them in at the end if you want. Cool, right? Now I'm going to show you how to code it. Disclaimer, this is for people with prior coding experience. First method I call recursive copy. Note that the upside down triangle is half the width and half the height of the right side up. For your geometry heads, this is because it's equilateral. I was going to prove it by side angle side or some shit, but I don't really give a fuck. It works. QED, let's move on. So you'll notice that the square that encloses the upside down triangle is 1/4 of the square that encloses the right side up triangle. Now normally what we do is we copy and shrink the right side up triangle, flip it, stick it back in, and then recursively do the same thing with all the new right side up triangles. But I got a trick to save you a flip. We're just going to scale the upside down one since it's already upside down. On the first step, we only need to put one upside down triangle, and it's pretty easy to figure out where to put it looking at the diagram here. 1/4 of the width over and half the height down. Gets a little bit more complicated after this, but not by much. Keep in mind, since this is recursive, we're now using the upside down triangle for width and height. We're going to put some measurements here to denote where the smaller ones are going to go in relation to the bigger one. So now we have the positions of the three new smaller ones and their sizes, and we do this recursively for each. Recursive split is up next. This one's even easier. You need the points of the right side up triangle as well as the points of the upside down triangle, and you denote point loops like this. Denote the points of the right side up triangle as 1, 2, 3, and the points of the upside down triangle as midpoints between them. Identify the loops as shown, and now you have point sets for the next three triangles. Do this recursively. Moving on, we've got a very exciting one. Bitwise and. You want to think of the coordinates of your screen in terms of their binary representation. Basically, you bitwise and the coordinate components of every pixel on screen. You change the color if the result is 0. Now let's see what happens. I'm pretty sure we can afford more than 16 fucking pixels, so let's try a bigger screen. Starting to see a pattern here. We could probably do this a lot faster if we just use our fucking brains, so let's try it. Wow.
Challenge alert, challenge alert.
I will personally cash app $1 to the first person who explains how this works. Post your over analysis in the comments below.